which is
f of x
fx, which is f cosine theta,
minus
right?
friction.
Minus the friction. How much is the friction? Mu. And the normal force. What was the normal force? By the way, this is mu s or mu k? Mu k because it's accelerating now. And what was the normal force before?
mg plus f sine theta.
Mg plus f sine theta. Since we know f now equal to ma, so the acceleration we divide by the mass. And this will be the way to find the acceleration. So you know now that the force have to be greater. So let's say 60 Newton cosine 37 minus 0.2 times the mass times gravity plus f sine theta divided by the mass, you get the acceleration. Any question? Approaching. So what is different from what we were doing? Now you add the topic of friction. And there are three situations. One when you don't get the minimum force, one when you apply more than the minimum force, which is moving, and one when you just apply the minimum force, which is you are in the transition. But depends on the question, right? You will use one of the three. But normally you have to remember this formula, mu k n, whenever you have to find friction, but n is not mg. A bad habit by the physics student is saying right away, Fn, mg, normal force, mg, wrong. It's incorrect. You can see there that the normal force is not mg. Sometimes it's mg. Under what situation normal force will be mg? When you are moving horizontally. When you are doing this, which you usually don't do this. Look how uncomfortable it is to do this. Right? That is the only situation when Fn is equal to mg. And that, practically, we never do it. Alright? The only thing that you do that is when you have a truck and it's level. The, how you call it, but pull the hook, whatever you use to pull the trailer, they are practically horizontal, right? In that case, it's normal force and mg is the same. But in this case, it's not. All right. Friction. Any question with friction? So let's say, so basically it's following. What you have to do in order to solve any problem, you can see that it's different. You will see the math. If you look at the board, you say, wow, what is this, how difficult it is, or how many formulas. It's not a formula, it's a system. As long as you follow the steps, you always will get to the right answer. But you have to follow the steps. Free body diagram, which Newton law, along which axis, then you just get the algebraical addition and you substitute. So if you follow the steps, the problem can be different, but as long as you get practice following the steps, you will get the right answer. This is the most important thing. It's not how to solve every problem. That can give the practice. But it's just to follow this. All right. The next problem. For example, let's say if I have this block, a poly, another block, there is friction, mu. I can ask, mu s is 0.3, mu k is 0.2, the mass here, let's say that is 5 kilograms. I can ask, what is the minimum mass that you will hang there to move the object? If I am asking for the minimum mass to move the object on the theory of friction, assuming that there is friction, in the theory of friction, which of the three cases we have to take in account? The second, because I'm asking for the minimum force. So to understand this, if I don't put anything here, what will happen? The object will move.
No.
If I will start putting a small mass. Not necessarily will move, right? Another mass, another mass, another mass. There will be a point when this will do and start moving, right? This is basically what I want. What will be the minimum mass in such way that this will pull the object. You will do the same. You will do the force here. What forces are acting here? So Newton's first law along x equal to 0 along y, sorry, on the second object. This is M1, this is M2. Let's say M2 and sigma f along x on first equal to 0. These are my two equations. What will be my equation along y for the second object? Tell me. Mg down, white mg first, because the tendency to move is in which direction? Down. So I will say mg of which body? M2 minus what force is here? Tension equal it's not moving. It's not moving yet. 0. And what will be the second equation for this guy? What force is to the right?
Tension minus friction.
Tension minus friction. And what type of friction if I am looking for the minimum mass?
Fs.
Fx, what type of Fs? Equal to 0. From these two equations, this tension and this tension cancels out, and I get that M2G will be equal to Fx max minus Fx max equal to 0, Fx max. And this is this. Can you see? Fx max equal to the minimum force to move the object, which is the second case. This is this. And what is Fx max equal to? Mu is n. And what is n in this case? There is a tension. Can you see that this is horizontal? In that situation, what did I say that is n equal to? Mg. What n? G cancels out. What we get? So if N2, if this is 5 kilograms and this is 0.3, how much is the minimum mass N2 that will move the object? If this is 0.3 and this is 5, how much will be the minimum mass? 1.5 kilograms will move the object. So anything above 1.5 will move the system. Anything below won't move the system because it doesn't overcome the friction. This is an application of the friction. Finally, the last